Hi everyone. Today I'm going to talk about 1.4 Math on AD Calculus Business. This session talking about introduction to limits. So in front of me right now having the figure with a graph fx. And my question in here is what is the value of fc? Okay, so in here that you see that as c at x equal to c on the graph it have like an open circle, right? Open circle. So what does that mean? That means there is no value. There's no value of fc. Okay, or then there is no value of x at x equal to c. So that means what? fc in here will be equal to DNE or doesn't exist. Okay, so if I ask you about the value of f x when x equal to c on the graph here, give me fc equal to DNE. Okay, now I don't want to talk about the specific value of fx when x equal to c, but I will investigate the behavior of the function around x equal to c. I want to observing the graph. Okay, so you see that. Let me change the color. You see that from the left side, if I go along with the graph, right? From the left side, I know that the graph moving to the graph moving toward to I mean the graph approach the graph gonna go up to L when X approach to C from the left side, right? You see that? I don't mean that it's gonna go exactly. It's gonna be stay exactly at X equals C, but it's approach to, okay? It's approach to C. So you see that the graph is trying to reach to L. Okay, so in here I'm gonna say the graph going to L. Okay, to value of L. Okay, and similarly in the other hand side or the right hand side, let me change the color. If I go from the right hand side, right, from the right hand side of the graph, it's going down and try to reach to L when X approach to C. Okay, so again, it's also going to L. So graph going to L. Okay. So all right. So now I'm gonna talk about the limits, definition of limit, and the limits notation. So if I say limits, it actually mean approach. Okay, if you see the word limit, it actually means the graph approach to something. So the the limits of fx as x approach to c is L, notate by this form. Okay, so I'm gonna call it like limit of fx when x approach to c equal to L. Okay, let's see the theorem down here. So if I have limits of fx when x approach to c equal to L, if and only if, okay, limit of fx when x go to c from the left hand side. Okay, so it's say x go to c negative on the top there. That means from the left hand side. Let me notate down here for you to make sure you know that. So it is limit of fx when x approach to c from the left hand side, which is negative here, will be equal to L. And same thing for this. I have limit of fx when x approach to c from the right hand side will also be equal to L. All right. So come back with the theorem. If you see the limits of fx when x approach to c from the left hand side equal to the limit of x when x approach to c from the right hand side and equal to L, okay, then you want to have limits of fx when x approach to c equal to L. Okay, so remember that in order to get limit of fx when x go to c equal to L, you need to check both hand sides if they are equal each other. Okay, so maybe I'm gonna have an example. You can see it clearly. So let's talk about example 2 here. I'm having a piecewise function, and the function is px equal to 20x minus 100 for the requirement as 0 to 150, and the other piecewise, the other piece is 20x minus 125 when x from 150 to 350. So let's graph this one and see what happened. So because I gotta consider the x from 0 to 350, so I don't want to really care about the negative sign. So from 0 to 350, right? So I say here is 150 and here is 300, and say 1, 2. So this one more. It's going to be 350 here. All right, and now that is for the value of x, and in order to have for a value of y, I need to maybe have like a table. Let me see. So I'm gonna have T table. Here's x. Here's for the first piece of px, going to be 20x minus 100. Oh, actually, you know what? I don't want to use it. I'm gonna make this like this. So here's x, and then px equal to 20x minus 100, and then I will have some value such as let's say 0, and let's say 145, let's say 150, and next one is 155. Maybe I have to change a little bit, because after 150 I'm gonna have new px gonna be px equal to, make this one clearly, to next month 250. Okay, so this will give me 125, 155. What else? Oh, I actually can start from 150 and let's see what happened. Even though it's not on here, but it's gonna be like open circle on this graph, right? So 155, and the last one will be 350. Okay. So I will have for the first value 0, I will have negative 100. Okay. Oh, so negative 100 is going to be down somewhere here. Okay. And what else? 145. So I'm gonna use 145 multiplied by 20, and then minus for 100. So I have 2,800. 2,800. Okay. And then 150 multiplied by 20 minus for 100. I have 2,900. So look like we have a big scale, but it still can work. So for the other, let's see, 20 times 150 minus for 250. I have 275, 2750, 2750. All right, and then 155 multiplied by 20 minus for 250. Gonna be 2850. And the last one is 350. Gonna be 350 times 20 minus 4250. 6750. Wow, this is a little bit big, but let's see how can I handle this. So I don't even need this down. I may gonna just talk about this. So maybe I'm gonna have h right here is 1000. So 2000, 3000, 4000. This one was correct. 4, 5, and then 6, and then 7. Maybe it's up a little bit. So 7000 is y, here's x. So I have negative 100. So maybe here, negative 100 and 0, right? Okay, so I have 1 point. Let me use another color. 1 point here. I have 2800 and 145 and 2800. So it's around here. 2800. 2800. There's 2800. 2800. going to be here. Okay. 150 to 900. Okay. 150 here and 2 900. So I have another one here. Okay. Okay. And now I know that's because in here you see that the 150 is a changing point. Okay, you should know that. So you may gonna draw a dot line that separate the two graphs. So the next graph, you have to know that for 150, px is 2750 will be open circle here, right? So 2750 for 150. Okay, so maybe not really easy to write, but it is open circle here. And then 155 will give me 2850. So 2850 here. And then 350 and 6750. 6750. Oh, let me see. So 6750 around here. So this is a graph of the second pieces. Okay, and oh, it's not really nice, but yeah, this one. Okay, and the first one is this one. Okay, so a little bit jumping, but that is just a way to graph. Now I'm gonna show you how to do to find the limits of this one. Okay, so for problem A, you see that they want you to find the limit of px when x go to 145, and 145 again. In here, 145 is not changing point. Okay, change. It's not changing point. And what else? 145 also is lie on the interval between 0 and 155. So 145 is belong to, I mean, I can just write 145 is greater than 0 and less than 155, 150. So you can right away plug in 145 into the first function, the first piece of the function. Because why? Because first thing, 145 is not in a changing point, and then second is 145 is just inside of the interval of the first part of the function. So I'm gonna just substitute into the first part of the function. It'll be 20 times 145 minus 100, and that's gonna be equal to 2,800. Okay. Now, if I want to talk about part B, okay, B, that's limits of px when x go approach to 150. In here, I know that's 150 is 150 is changing point. So note 150 is changing point. Because why? Because both the first part and the second part that that have 150. Even though the second part is say greater than 150, but use because this is talking about the limit, talking about approach. So then you have to consider this changing point. Okay, so since it is a changing point, then you have to find the limits of px when x go to 150 from the left hand side, from the left hand side, and if I talk about and another one is the limits of px when x go to 150 from the right hand side. Okay, so so from the left hand side is based on let me change the color here. Is based on the first piece of the graph, which is 20x minus 100, right? So you're gonna plug in 150 into the first part. So it's gonna be 20 times 150 minus 100, and that you're gonna have 2,900. Okay. For the limit of px when x approach to 150 from the right hand side is actually based on the second part is here. Okay, then you're gonna have 20 times 150, and you subtract for 250 to get 2750. Okay, and they asking me for the limits of px when x go to 150. Okay, go back to the definition of the limit. You should, or the theorem actually, you should know that in order to get the limit of fx when x go to c, you need to have both hand side of the limits when x approach to c from the left or approach to c from the right equal each other. Okay, but in here, take a look at the limits of px when x go to 150 from the left and x go to 150 from the right. They are not equal each other. Okay, so I'm gonna say limits of px when x go to 150 from the left is not equal to the limits of px when x go to 150 on the right. Okay, so limit of px when x approach to 150 is does not exist. Okay, so remember this. Okay. For problem C's, they want you to do limits of px when x go to 155. Remember that 155 is not changing point, right? So look at the graph. 155 is somewhere over here. It's not at the 150, so it's not in the changing point. So yeah, so you should base on the second part of the function, and so you just substitute into the second part. Gonna be 20 times 150, so 155. So 155, and then minus of 250, and then you will get what is that? 2850. Okay, 2850 gonna be the limit of px when x go to 150. Okay. Now I'm going to talk about direct substitution for the limit of a polynomial functions. So usually for all polynomial function, I mean not usually, always for all polynomial functions, such as ax squared plus bx plus c, or something like that, or like ax plus b. There's no complicated thing. It's just gonna be adding between some some terms. So you can just direct substitution in order to get the limits. So in here, I have limits of fx when x approach to 2, right? And I know that fx equal to 3x squared minus 5x. So I'm going to change it to be limits of 3x squared minus 5x plus 1 when x approach to 2. And like I say, you're gonna just direct substitution. What does that mean? You're gonna just substitute x equal to 2 into the function. You're gonna get 3 times 2 squared minus 5 times 2 plus 1. See that? All the x now become 2, right? And the answer should be, what is that? 3 times 4 is 12, minus 10 plus 1. And the answer should be equal to 2 plus 1 is 3. I hope it's correct. Okay. One special things. If the limits, if you are looking for a limit of a constant function, such as fx equal to a, then the limit of fx when x approach to anything, in here I say b, will always stay at a. Okay, so that is one of the formula that you need to know. And for example, you have fx equal to 4, then if I ask you about find the limit of fx when x go to 7, then right away you're gonna say it equal to 4. Okay. What about limits of fx when x go to 100? Still is 4 because it stays forever at 4. Okay. So now now let's talk about limit of a rational function. This is a little bit complicated, so focus on this. In example 5, from the text, I have fx equal to x squared minus 3 over x plus 5, and I want to find limit of fx when x go to -2. So I'm gonna change this, become limit of x squared minus 3 over x plus 5. and x go to -2. Okay. So always, the first step is direct substitute. Okay. First step, direct substitute. If you see a limit with a finite number, you just direct substitute first to see what happens. All right. So I have I'm gonna plug x equal to -2 into. So I have -2 square minus 3 over -2 plus 5. Okay. I did plug x equal to -2 into the fx. So now I have 4 minus 3, and bottom going to be -2 plus 5 equal to 3. And then finally, I simplify, it's going to be equal to 1/3. That's going to be the answer. Okay. In this case, there is no problem after the direct substitute, then you can right away to derive to the answer. Now, what happened if I have you have problem? And let's see what's that problem. Okay, so they want you to find the limits at x approach to 2. Okay, for fx equal to 3x squared minus 2x minus 8 over x minus 2. Okay, so I'm gonna have limits of 3x squared minus 2x minus 8 over 2 over x minus 2 for x go to 2. Okay. So first step, direct substitute, right? I will have 3 times 2 square minus 2 times 2 minus 8 over 2 minus 2. Oh, I see that bottom become a 0. Okay, top become something. So that's going to give me a DNE, okay, or like an undefined, okay, because the bottom is 0. So I need to move to step 2. I need to factor all top and bottom of the fraction. Okay, so so now what happened? Let me move it to here, and I have I will have factor the top first. I have 3x squared minus 2x minus 8 going to be equal to what? Using AC method, 3 times -8 equal to -24. And -2 here. Here is plus and here is multiplication. So two number addition equal to -2 and multiplication is -24. So I'm gonna say -6 and 4. Okay, so that's work. And because a in here is equal to 3, then you cannot use not a successful case. So you're gonna split the middle one, become -6x plus 4x, and keep the other term 3x squared minus 8. And then using grouping method to factor it. So I have 3x For the first term, going to be 3x times x minus 2. And then second two term going to be the two last term going to be 4 factor out and then x minus 2. And you see that there is a common growth, which is x minus 2 when you look globally. So you factor x minus 2 out to get 3x plus 4 as another factor. So now I can change the top become 2 factor, and I'm gonna rewrite is here as limit of x minus 2 times 3x plus 4 divided by x minus 2, and this is for x go to 2. Okay, and remember that if in the limits, when x go to 2, that means x is not equal to 2. X is trying to approach to 2. So I can easily cancel. The common factor between the top and bottom. And remember that I can cancel in this situation because they are all factor already. Okay. All right. And now I'm gonna have limits of 3x plus 4 for x approach to 2. And now it's time to, now it becomes like a limit of polynomial, okay? So I can just direct substitute. So it's gonna be 3 times 2 plus 4. And that's gonna give me equal to 6 plus 4, which is 10. So that's going to be the answer. Okay. So now let's talk about some properties of the limit. So one of the properties you need to know is limit of a sum of all difference. In here you can actually split it, become 2 term or even 3 terms. So for example, now 6 here, if I have limits of x of the 4x squared minus 2x plus 5 over x. All right. Then when x goes to -1, then I can split it to become instead of only 1 limit, I can split it become 3 limits, and by split each term here, right? So I have limit of x go to limit of 4x squared when x go to -1 minus for limit of 2x when x approach to -1, and plus with the limit of f of x when x approach to -1. So that is very simple, right? But usually honestly I don't really like use this queries, but you just need to know that sometimes maybe you need it for some complicated one. Usually in our class you don't even need to use it. You just right away direct substitute into this polynomial, right? Okay, now let's move to the second one. Limit of a constant times a function. Okay, constant time a function. What does it look like? So I have, for example, I have fx is a function, okay, and limit of fx exists, okay. Then, okay, limits of k fx, k in here is a constant, okay, will be equal to k times the limit of fx when x goes to c. Well, you can move the constant outside, get out to the limit, right? And and the limit of a product of the function is similar with limit of sum and or difference. You can also split it to become two limits multiply each other. Okay. So for example, 7 here. Okay. They want me to find say A. They want me to find limits of 5x squared when x go to 1. Okay, you see that. There is constant here, number 5 here. You can actually move out to the limit and get limit of x squared when x go to 1. But actually, you to me, usually I'm gonna just direct substitute because this is like polynomial. So in another way, I'm gonna just have 5 times 1 square equal to 5, right? For the other, for the first method here, after I move out number 5, I can direct substitute into the limit. So I'm gonna have 5 times x square, oh, I'm sorry, x square now become 1 square and become 5. So same answer, but yeah, but just shorter way. So these three police to me, I don't really like consider that because it's just for you when you do some complicated one. Okay, so what about B? B, you see that there is limits of 2x minus 3 times x squared plus 1. Okay, maybe you want to think about the distribution for the limits for the inside of the argument of the limit. But I'm gonna say, oh, no, you don't have to do that. You're just gonna maybe substitute, direct substitute right away, or you can just split it to be two limits, multiplication each other. So say limit of x go to 1, for x go to 1 of 2x minus 3, and multiplied by limits of x squared plus 1 when x go to 1. And then you're gonna substitute directly. You have 2 times 1 minus 3. And then, oh, you should have parentheses for this multiplied by 1 squared plus 1. And then simplify, you have 2 times 1 is 2 minus 3 is negative 1 times with 1 squared plus 1 is 2. Then you're going to get negative 2 as the answer. So far, so good. And now we're going to move to determining limits when the police do not direct apply. Okay. So it's similar with the example 1 that I just show you above here. That you that when you do direct substitutes, you get D and E, then you have to factor. But if it even not cannot factor, let's see what happened, right? So here, for problem 11, if I want you to find fx when x equal to 2, so easily it's going to be equal to limits of 1 over x minus 3 square when x go to 2 and and you're gonna direct apply that substitute that. Okay, so first I have 1 over 2 minus 3 squared. Then I'm gonna have 1 over -1 squared, and that's still equal to 1 over 1 and equal to 1 with no problem at all. Okay, so this is clearly easily to get the limits because there's no problem. There's no issue with the bottom. Now, what happened if x approaches to 3? So I have limits of 1 over x minus 3 square when x goes to 3, and then you see that top become top cannot factor, bottom, okay, you can factor, but it will not help you to cancel anything. So just gonna apply substitute. So let's see, I have 1 over 3 minus 3 square, then you have 1 over 0, then you will have do not exist. Okay, in this case right away, if you cannot factor anything, then you have and you still have 0 at the bottom, then you're going to say the limit become do not exist. Okay, move to example 13. Let's do one more, two more example here. Let's see what happened. Okay, so I have a limit of x squared minus x minus 2 over x minus 2, and easily if you I'm gonna say noted that direct substitute for x it go to 2 will get do not exist, right? We'll get undefined. So I just right away do second step by factor. Okay, so try factor. So I'm gonna factor top, bottom cannot factor anymore. So the top gonna be AC, in this case A equal to 1 already, so that's a special case. A times C equal -2, B is -1, two number multiplication equal to 2 and addition equal to -1, which is -2 and 1. Yeah. So I'm gonna have I'm gonna change it, become limits of x go to 2 for the function is x minus 2 times x plus 1. Because a equal to 1, then I can just right away factor it easily by these two numbers. So x minus 2 at the bottom. And now after I factor everything already, I can cancel the common factor between top and bottom. So now I'm gonna have limits of x go to, x plus 1 when x go to 2, and lastly just direct substitute, which is equal to 2 plus 1 and equal to 3, right? Okay, I did give you like a bunch of example, and I hope that you have some ideas in order to find the limits of a finite number. But there is only one case that maybe is complicated. In here, you may have to think about there is the case that with radical and rational at the same time. So so in this example 14, I have limits of x go to 4, I mean of square root of x minus 2 over x minus 4 when x go to 4. And if I use direct substitution, it will give me 0 over 0, which is undefined. Okay, so I have to think about can I factor or do something for this guy. You know what, for the factor I don't recommend. I mean it's not easy to see the factor, right? But in this case, if you see a radical, you will think about trying to multiply with the conjugate of that group. So what's a conjugate? So conjugate of square root x minus 2 is square root x plus 2. You're going to multiply with the conjugate of that in order to get the difference of completing a complete square. So let's write that. So I have limits of x go to 4 for square root of x minus 2 and x minus 4. You're going to multiply the top. I'm going to change the color. You're going to multiply the top with the conjugate of square root minus x minus 2. So that's square root x plus 2, right? And you have to multiply with the same thing for the bottom, which is square root x plus 2. And then you will have, now, this exactly the formula for the difference completing square. So you will have square root x squared minus 2 squared over x minus 4 times square root x plus 2. If you remember that, okay? Remember the formula, the mark. Say a squared minus b squared equal to a minus b times a plus b. Okay, that is a formula that I did apply on this one. Okay, so now, oh, I forgot a small thing, and nobody think of that. That is a limit. Okay, don't forget to write the limits. So limits. Now I'm gonna simplify. Top gonna be what? Square root of x squared gonna be x minus 2 squared gonna be 4. Okay, top gonna be x minus 4. What I'm gonna be x minus 4. Don't ever distribution do distribution for this guy, because you are trying to cancel something for the factor. So okay, so I have square root of x plus 2. All right, and x approach to 2. So now I noted that there is common factor between top and bottom, which is x minus 4, and I cancel that. And I will get a limit of x go to 2 for the function we is 1 over square root x plus 2. And now I can direct substitute without issues of the undefined. So 1 over square root of 2 plus 2. All right. Maybe you can use a calculator to find exactly what is that number here. but I'm gonna just stop here because I'm lazy for using calculator. Okay. Now let's move down and talk about lastly in here, which is limit involving infinity. Okay, so you above is when x go to finite number like a 2, 3, 4, 5 when x approach to that number. But now if I say x approach to like very large, like positive infinity or negative infinity. Okay, so what happened with that, and how can we handle that, right? So remember that you will have two probabilities, and this will stay with you forever in order to do the limit involving infinity. Okay, so first one, limits of x to power n when x approach to infinity will be equal to infinity, or we're gonna say do not exist, where n has to be greater than 0. Okay, so so if you consider why that, maybe you're gonna think about like if you have x power 100, right, and or even x equal to 1 or something, x over x power 1 also, right, in the limits when x goes to infinity. What happened for x power 1? It's just x, right? If x goes to infinity, when it's direct derivative, right away it's going to be infinity, right? So similar with that for all the other, but remember that n has to be greater than 0. Okay. Now for the property number 2, if I have limits of 1 over x power n, when x goes to infinity, is will be equal to 0. This will this is one of the property that's really helpful for you to do the limits involving infinity. And remember that n still is greater than 0. Okay. So now let's do some example. So example 15 want me to find the limits of 5x squared plus 7x minus 2 over 8x squared minus 3x plus 1 when x approach to infinity. Okay, so remember that in this case it is x go to infinity. Okay, so my first step is so I'm gonna say dividing numerator and denominator of our function by x squared. Okay, so I'm gonna say step 1, dividing top and bottom with the highest highest degree of the bottom higher degree higher with the higher degree variable term in the denominator or in the bottom. Okay, so that is step 1. And then step 2, I'll tell you later. So in this column, you see that the highest degree variable at the bottom is x squared, right? See that? The highest variable here is x squared. So I'm gonna divide both top and bottom by x squared. Okay. So so I have 5x squared divided by x squared gonna be 5, right? And 7x divided, oh, let me see what happened. Why it's become, oh yes, that's right. 7x divided by x squared will be 7 over x minus 2 over x squared. Yeah, that's correct. But now, let's think about this term, 7 over x. Okay, so if x go to infinity, right? So using two probability from the limit to simplify. Okay, so go back to the first and the second one here. You see that the second one here have limits of x go to 1 over x power n when x go to infinity. Okay, so in here, if I say limits, let me write down here. Right. Oh. Okay, so note that if I'm asking you about limits when of 7 over x here, when x goes to infinity, you will get what? Limits, you can just say 7 times limit of 1 over x when x goes to infinity, right? And now for this part, it becomes 0. 0, right? Because the probability number 2, you can see that when you plug in like x equal to 99999 into 1 over x, then it becomes 1 over 999, and it's go to 0 later. So this become 0. 7 times 0 become 0 for that. Okay. Similarly for 2 over x squared also will give me 0, and 3 over x becomes 0, 1 over x squared becomes 0. So we left out only 5 and 8 here. So I'm gonna say limit of this function will be equal to 5 over 8. Okay. Let's do 2 more examples. So in here, in number 16 here, I'm gonna say step 1, divide top and bottom by the highest degree highest degree variable in the bottom. What is that? X squared. That is highest degree. Okay, so it is x squared. So I'm gonna divide both top and bottom by x squared. So I have limit of 8x cubed divided by x squared plus 7x divided by x squared minus 2 divided by x squared over 5x squared divided by x squared plus 3x divided by x squared minus, no, plus 11 over x squared for x go to infinity. Okay, now it's time to simplify. I have equal to still limit. Now 8x cubed over x squared going to be 8x plus 7 over x, right? Minus 2 over x squared, right? And bottom will be 5 plus 3 over x plus 11 over x squared. And as you can see, all this gonna be equal 0, right? Because that is in probability number 2. Okay, so step 2, apply to probability. Okay, but there is one term that will not go to 0, which is ax, and that will go to infinity because of the first probability here, right? The first probability say limit of x power n will be equal to infinity, and then here I have x power 1. Okay, it's not x is not at the bottom of a fraction, so it will be go to infinity. And now I'm gonna I mean, like, maybe I'm gonna have one more step. So I will have equal to limits of x go to infinity for 8x over 5, and this will go to infinity. So it equal to infinity or do not exist. Okay. So you can see that in this example 16, the degree of the top is higher than the degree of the bottom, and that will usually give you do not exist. Okay, so note that, and degree of top greater than degree of bottom will give you limit involve limit with infinity becomes do not exist. Okay. What about the case that the degree of the top is less than the degree of the bottom? Okay, so I have example 17 here, and again I will still have to divide top and bottom with the highest power of the bottom. In this case is x squared, right? So I have 7x over x squared minus 3 over x squared over 2x squared plus 5 and over x squared. Okay, so easily you can notice that you can simplify it, become x 7 over x minus 3 x squared over 2 plus 5 over x squared. And you should know that the top will be, this becomes 0, this becomes 0, this becomes 0. And you will have equal to 0 over 2, which equal to 0. So that means that degree of the bottom, degree of the top is less than degree of the bottom, will give you the limit with infinity become 0. Okay, so I have finished my section 1 for today. I hope that you understand this. This is a little bit complicated section, but you can just rewatch the part that you not understand in my video. And if you're still not sure what happened, you can attend my my live Zoom class and let me know the question. I will give you more example and helps you to make sure you understand this section. Okay, so make sure doing your the homework and your quiz for this week. I see you next time. Bye.